Welcome to Math Soul. In this video, we are going to see the trigonometric functions sine theta, cos theta, and tan theta when the angles is coming with a different magnitude. So angle could be the acute angle, or it could be a obtuse angle, which is more than 90 degree and less than 180 degree. And then the angle, it could be even the reflex, which is just the more than 180, you can see. So here I just try to introduce you the unit circle to explain how we can read when the angles is coming to any magnitude, so from 0 degree to 360 degree here. So now let's start with the unit circle, and you can see that circle with the radius 1. And if I say what is the point here, it is 1 0. And if you see what is that coordinate, is 0 1. So it's maximum, the radius is 1, and here is the minus 1 0, and this is the 0 minus 1, is the negative side of y. Okay, and then we know that the x coordinate is represented by x equal to cos theta. So x is coming basically cos theta, because the unit circles usually x equal to r cos theta, but in this case is r is 1. And then y is coming to y equal to sine theta. So what I'm trying to say here, that the coordinate x coordinate is cos theta, and then the in a point that y coordinate is coming as a sine theta. So if I say what is that point, in the angle is theta and this is p, so I can say the x part will be the cos theta, and then y coordinate will be the sine theta. And that's how when it's a 0 degree, because when we are talking about the x-axis, it is 0 degree. So we know that cos 0, this is basically cos 0 degree, which is 1, and then sine 0 degree is giving 0. And same way, how we got 0 and 1, because cos, again the x part is for cos, so it's a 90 degree position, so cos 90 degree is 0, and cos 0 degree is and then sine 0 degree, sine 90 degree equal to 1. Okay, so sine 0 0, sine 91. So this is basically sine 90, which is giving us 1 right here. Okay, so now we know that that point is p of cos theta, sine theta, depending on the theta. So when you are moving that p, okay, when you are moving that p, you can see the cos theta is coming to 0, and then sine theta is being maximum is 1, right? And then when you go to the more than 90 degree position, so for example we are reaching at q, and the reason I'm choosing q is because it could be anywhere, but I'm choosing q anywhere in between that second quadrant. So we are moving from more than 90 and less than 180, with its that part, it is the second quadrant, and I'm choosing a q in a position where it is exactly the cos theta and sine theta. So I'm talking the angle is exactly the theta. So the reason is then that your cos theta sin theta will not change, because the all the triangles, actually there are, you can see there are 4 triangles I try to plot here. All are, I'm just taking theta position, so that sin theta and cos theta will be the same, because their sides are same. And basically all these 4 triangles are the right angle triangle. I can put a right angle here. So all are right angle triangle, and they are congruent triangles. So congruent means all these sides, so 3 sides, and for the second triangle and third, fourth triangle, the sides are same. So it means when I'm doing the cos theta or sine theta, yeah, your theta is the same, opposite is the same, and then opposite over hypotenuse. Hypotenuse is also the unit radius, which is r equal to 1. So opposite and hypotenuse is the same. So sine theta will be the sine theta for all these. Only the thing is the sign, the plus or minus will change, because when I'm coming to the second quadrant, you can see the cos theta, because cos theta is the x, right? So x coordinate. So our cos theta will be the negative, because we are talking about the negative side, right? So we are talking the negative x. So it means the for the q, the value is a cos theta sin theta. That's true, cos theta and sin theta, but our cos theta in this case will be negative, because we are talking the negative x coordinate, but our y coordinate is still positive, because we are talking about the positive, this is the positive side, right? So it's a positive y, so that's why sin theta is still positive. Okay, so when you look at r, again as I said, the theta is the same. If it is a 30 degree, all are 30 degree, and it is a right angle triangle, and so it's the opposite of adjacent sides, and we are making the triangle based on the x. You can see this is the same arm sharing, right? So now what happening here, you can see in that r, x is negative and your y is also negative because you are coming down to the y direction, negative y direction. So it means it is giving you, if I write down the coordinates of r, it is minus cos theta and also minus sine theta, right? And then if I move to s, what is the coordinate of x? Then you can see that your s is in the positive side of x, so it means cos theta will be positive because it's the positive side of x, but the y is negative, so it's coming down to the negative direction, so which is and y is sine theta. We know that y coordinate is sine theta, right? So it means our cos theta is positive, but sine theta will be the negative in this case. Okay, now if I want to show you that how we can read it for different magnitude, I will show you. But before that, we can I can just draw another just to show you the quadrant. So we have just showing that you have that is the quadrant 1. We know that this is our second quadrant, right? And this is our third quadrant, just putting here third quadrant, and then we have a fourth quadrant. This one is a fourth quadrant, right? So we are doing exactly the same thing, but now I am writing in the first quadrant. You know that your sine theta and cos theta both positive, so I can say sine theta is positive here, cos theta is positive here. So if sine theta and cos theta positive, we can obviously say, we can say that our tan theta will be positive as well in this case, because tan theta is coming by sine theta over cos theta. So if you divide sine theta over cos theta by cos theta, then you are getting tan theta. So when sine and cos both positive, you are obviously getting tan positive. Okay, now when you are doing, you're coming to the second quadrant. So interesting thing is, so when I'm coming to the second quadrant, it is we have to read, like I can just use the different color in case so you can see that second quadrant, I am coming that line. I am just thinking that we are in here now. So what is the angle it is creating? So read that angle now. So it is basically 180 minus theta, because you can see that the total is 180 if you come down up to here, but we are not coming up to here. We are stopping here. Okay, by making the acute angle. So it's 180 minus theta to reach up to that line. So I can say it is sine of 180 minus theta. Okay, and this is equivalent to what? You can see it's a sine theta, because sine theta is positive, you can see here. So sine theta, and if you do cos for that, cos of 180 minus theta, so it's a minus cos theta, because at that point you can see that the coordinate is a negative. And how it is negative, I already explained that. And then if I do tan of 180 minus theta, then it is giving sine theta divided by minus cos theta, which is giving you minus tan theta. So in the second quadrant, you can see only the sine is positive, cos and tan is coming negative. Okay, now let's say we are moving to the next quadrant, which is third quadrant, and here, so in that line, so we have to come up to that line. So if you come to the from the positive x-axis, the angle would be the positive when you come like that, right? So if you come like that, okay, then it is, you can see obviously it's 180 plus theta. So if you come 180 up to here, then plus theta, so 180 plus theta. So I can write down sine of 180 plus theta, and then what you are getting, minus sine theta. Okay, cos of 180 plus theta, you are getting minus cos theta. And then if you do tan of 180 plus theta, then obviously you can see sine over cos, and both are negative, so negative over negative is cancelled, so we are getting positive tan theta. So in the third quadrant, you can see sine and cos both negative, only tan positive. Now if I want to go to the fourth quadrant, let's say I'm using the another colors, and we are going from again the for positive x-axis, and you are going up to the line up to here. So if you go up to here, it means we are reaching for that theta, right? Now how to get the angle here? So we can easily, if you go up to here, it's a 360. So 360 minus theta is up to here. If I come down like that, 360, then it's not 360, it's less than that. It's a theta is less here, so 360 minus theta. So I can say sine, we can read like sine 360 minus theta, and what is giving is the minus sine theta. Okay, and then for cos 360 minus theta, you are getting positive cos theta, and then tan 360 minus theta, you are getting it's a sine theta over cos theta, but it's a negative, so negative tan theta. And if you look at carefully here, for the fourth quadrant, you are basically getting only cos theta positive, and all sine and tan will be the negative. And the students often remember like that. If I just use that term, all, I can just write all student take chemistry. So all positive for the second quadrant, sine positive, for the third quadrant, tan positive, and for the fourth quadrant, cos positive. So all student take chemistry. So that's how you can remember. And this understanding of how it is positive and negative is very important. So you don't need to memorize it as long as you understand, and it is very useful when you are solving the trigonometric equation, and also when you are trying to simplify a trigonometric function with a large angle. Let's say we can start with an example. Let's say we have the problem with the sine of 120 degree, and I'm asking you how to simplify it. So it means we are trying to get the value, or we are trying to reduce the angle and make the angle, or it's a reference angle in the first quadrant. So we are trying to get the acute angle, and you know this is the obtuse angle more than 90 degree. How to make it? So if you know that 120 is basically sitting here in the second quadrant, what you can do, you know that it is for the second quadrant is 180 minus theta, and theta is the acute angle. So you can just write down sine of 180 minus, what is the value that can make that 120? You know 60 degree can make 120. So 180 minus 60 will make 120. And then so it means sine of 120, you can easily write down sine of 180 minus 60. And you know that it is in the second quadrant, and second quadrant sine is positive. That's why I said the sine is positive in the second quadrant. To know that is very important, because then I can just straight away write it is sine of 60, because we know that sine of 180 minus theta is sine theta if it is in the second quadrant, and as long as we know that 120 is the second quadrant, sine of this will be sine of 60. Okay, and then if you just write down the value, you can just, you know, the sine 60 means square root 3 over 2. If you want to get the exact value of sine of 120, then you can do like that. So in order to get the exact value, you have to simplify that in that acute angle and then get the value, right? For example, if I say we have a problem with the tan of, let's say I can just do another problem, which is tan of 315. So in initial filling at 315 is in the, is more than 270 obviously, and it is in the fourth quadrant, right? So in the fourth quadrant, what we need to write down 360 minus theta, because in the fourth quadrant you need to go. So always remember that whatever you're writing, like let's just write here first 360. I am writing either 180 or 360. If you look at here, 180 or 180. So when we are in this second and third quadrant, we are writing the angle based on 180, because we cannot try with the y-axis. We always have the angle based on the x-axis, right? And then when we are coming to the fourth quadrant, then we are using 360 degree, because that's in the x-axis. Okay, so 360 degree minus 45 is giving us 315. So I'm just breaking the 315 in terms of 360 minus 45, like that I explained here in the fourth quadrant. Now you know that tan theta in the fourth quadrant is negative, because only cos is positive, we know that. So tan is negative, so negative 10 and then 45, because it's saying that tan 360 minus theta will be minus tan theta in the fourth quadrant. So I'm just writing minus tan theta, and you know that tan 45 is 1, so you can just write down it is negative 1. So tan 315, if I want to get the exact value, you can just simplify, get the acute angle, and then get that 315 is equal to -1. I know if you put in calculator you will straight away get the answer, but most of the time the students can be asked to get the exact value without using calculators. So you might need to know these skills. And also it is very important to know, because when you are solving the trigonometric equation, obviously we need to know these concepts. Thanks for watching. Please subscribe my channel to see more up-to-date videos.